Today, we're digging into a standard that's at the heart of modern aerospace software, DO-331. And trust me, this isn't just another document. It's the official rulebook for a huge shift in how we build things, the move to model-based development. So, in a nutshell, model-based development, or MBD, starts right here. Instead of writing endless pages of text requirements, engineers actually build these graphical, executable models that show you exactly how a system is supposed to behave. And then, from those very models, the source code gets generated automatically. Now, this is where verification gets really clever. You can run tests against the model, and then turn around and run those exact same tests against the code. It's a way to prove that what the model says is exactly what the code does.
This creates a really interesting intellectual puzzle, doesn't it? I mean, if the model is dictating the behavior and the code is just an automatic output, then what is the actual software? Which part do we certify? Is it the model, the code running on the box, or have they both become the software?
Well, when it comes to certification, there's no room for ambiguity. You absolutely need a clear, definitive answer. And that is precisely what DO-331 is for. It gives us the structure to answer that question and maintain the rigor we need for airborne systems.
All right, here's how we're going to break it down. We'll start with what model-based development really is. Then we'll introduce the DO-331 supplement itself. After that, we'll get into the core concepts and verification. And finally, we'll talk about what this all means for certification in the real world.
Okay, first things first. Let's make sure we're all on the same page about what model-based development really is. So, MBD is an engineering approach where this high-level, abstract model becomes the star of the show. And it's not just a pretty picture. It's an executable specification. You can actually use it for analysis and simulation way before you've written a single line of code for the target hardware. These models, they contain the real guts of the software. The system logic, intricate state machines, the precise control laws for something like a flight control system, and the signal flow between different parts. And because you can run them, you can find design flaws super early. Then, the automatic code generation keeps a perfect, traceable link from what the system was supposed to do all the way down to the final proof that it does it.
And this is the absolute key shift you have to understand. The model is no longer just a static drawing in a document that an engineer has to try and interpret. It becomes the active, living thing that literally drives the implementation. It is the single source of truth for how the system works.
But you can't just flip a switch and start doing MBD. It requires some serious engineering discipline. For a lot of teams, this is a huge paradigm shift. You're moving your focus from line-by-line code reviews to a really deep analytical review of the model itself. And that means you need dedicated modeling experts, clear standards, and really robust configuration control for these models.
Which really brings us to this critical point. Model-based development is a whole methodology. It's not just some new software you buy. It demands organizational commitment, a real change in how you do things. You can't just tack it onto a team that's already swamped and expect it to work. It's a genuine strategic shift.
Okay, so let's get to the standard itself. This is where DO-331 enters the picture, giving us the official rulebook for how to use MBD in a way that can actually be certified.
So DO-331 was put together by the very same groups that gave us the cornerstone standard, DO-178C. And its whole purpose isn't to replace DO-178C, but to supplement it. It gives you specific, extra objectives you have to meet if and when you decide to use models as a main artifact in your development.
It's really important to be clear on what DO-331 is and what it isn't. It is a supplement that basically modifies how you go about satisfying DO-178C when you're in an MBD world. What it is not is a standalone document, and it's definitely not a sales pitch for MBD. It doesn't say you must use models. It just says, hey, if you choose to go this route, here are the rules of the road.
All right, let's get into the technical nitty-gritty. How does DO-331 actually manage the certification process when software is built this way?
DO-331 really zooms in on a few key areas. It lays out objectives for how to treat the model as a formal requirements document, how to verify the model itself with things like simulation, and how to manage the whole code generation process. It also puts a huge emphasis on traceability and, this is a big one, the formal qualification of your tools.
And here is another one of those essential mindset shifts. Just because the code is generated for you doesn't mean verification just disappears. Not at all. It just moves upstream. Now, a huge chunk of your verification work happens right at the model level, long before a single line of C code even exists.
This leads us right to another standard, DO-330, which is all about tool qualification. Think about it. If a tool is automatically writing your flight code or formally proving your model is correct, you better be darn sure that tool is trustworthy. And that's exactly what tool qualification is for.
The key thing to remember is that DO-331 and DO-330 go hand in hand on an MBD project. You can't really have one without the other. DO-331 sets the process rules for using models, and DO-330 gives you the rules to prove your tools are reliable. Without a qualified tool, your code generator is basically an untrusted black box, which makes certification under DO-331 pretty much impossible.
So what does this all actually mean for an engineering team on the ground? Let's connect this back to the practical, real-world implications. Look, DO-331 doesn't live in a bubble. It fits neatly into this whole ecosystem of aerospace standards. You've got ARP4754A guiding the overall system process, ARP4761 for the safety assessment, and of course the foundational DO-178C for software assurance. DO-331 and DO-330 are just very specific add-ons that plug right into that software piece. In practice, MBD can be a double-edged sword. When your processes are sharp and your teams have the right skills, it can be amazing for consistency. But if you try to force it onto a team without proper training, or you cut corners on tool qualification and modeling standards, it's just going to add a ton of complexity and risk. It fundamentally shifts where the heavy lifting of engineering happens, from the code to the model. And this really brings us back to the core truth of certification. At the end of the day, the process is and always will be based on providing objective evidence. Model-based development doesn't let you get away with less rigor or less evidence. It just changes what that evidence looks like. Your proof might be a formal analysis of a model now instead of a code review, but the burden of proof is exactly the same. So, what's the bottom line here? The professional takeaway is this. DO-331 is the framework that guarantees that even when we use models as our primary artifact, the certification process stays structured, traceable, and completely driven by evidence. Model-based development is an incredibly powerful approach, for sure, but that power is only really unlocked when it's backed up by equally powerful and disciplined engineering processes.